So hi there, I hope you are doing great. So now I am going to show you how to import the spice model of a particular component that is not available in the Tina TI. So for example, uh, I need a MOSFET BS170, which is typically used in a level shifter circuit. So it converts 5 volt to 3.3 volt. So when I search it in the Tina TI library that is available by default, it is not present. So let's see if it is available in the web as spice models. So when I search on Google BS170 spice model, uh, a lot of websites show up. So if I click the first website, you can see there are the first line is a simple model, and second one is seems to be more complex, and there is also a third one. And also we have also the model from the manufacturer itself. So BS170 produced by onsemi company. So when we go to this website, we have like technical documentation, and in the bottom side we have this simulation model spice. So if we download this, it will be downloaded as a dot mod file. So the challenge is these things cannot be directly imported in Tina TI. So there is a new macro wizard here where we can load .cir files. Usually it shows a lot of errors because these syntaxes are usually not directly supported by Tina TI. So you have to make some modifications. But which modification needs to be done is a bit troublesome to learn. And imagine you are importing a 200 line model, so you have to go through each of the lines and find out where you have to make the changes. So it is a very troublesome work. So we have Google Gemini here. So today we are going to use this to convert these text or the spice model available online to a .cir file that can be directly imported in Tina TI without any errors. So let's copy one of these things. So let me copy this text here, Control C. So now I'm going to paste this here and ask Gemini to convert it to a .cir file that I can import in Tina TI without any errors. So here I have a uh, spice model of BS170 N channel MOSFET. Convert it to a .cir file that I can import into Tina TI. So Control V, and I'm pasting it here. Let's see what Gemini does here. Okay, so it gave us this text. So let me just copy this and let me open a new text file. So BS170 test2. Sorry, let me change the extension as well. It must be .cir. Okay. Now let me open it in Notepad and I will paste the copied text from Gemini. So I will save it, Control S, and now let me go to Tina TI again, and now from tools and new macro wizard. So let me set the name here. So BS170 test2. Okay, so from file, so this is the one. Okay, next. So now we have to set up a symbol. So let me first check it from library. So here you will see a lot of predefined symbols. Sometimes symbols do not show up here, so then you will uncheck it. The show suggested shapes only. So if you uncheck it, then a lot of symbols will appear. So right now I have what I need here. So let me choose a enhancement type NMOS-E. Okay. So next. So now we have to match these pins to this here. So 3, 4, and 5. These were marked in the file, and the MOSFET has drain gate source. So you will find things here usually, or one of the pins will be connected. Yes, you may find it like this. So now we have to match the pins. So in Gemini, you will see that uh, it should mention which pins are connected to which. Okay, so let me check. Yes, the node numbers 3, 4, and 5 correspond to drain, gate, and source. Okay, so 3 is the drain, 3 is drain, and 4 is gate, and 5 is source. Okay, so once it is done, we click next. So let me save it here. So the macro file is ready to use. It can be inserted by selecting insert or macro, or by pressing insert button below. Okay, so let me finish it just here. So later on I can click insert macro. So PS170 test 2 open. Okay. So let me show you the transfer curve real quick, like the output versus input. So I will place a source here, another one here. So I will vary the gate to source voltage and observe the drain to source current. So ID versus VGS characteristics. So let me put a resistor here to limit the current, and I will also place an emitter here. Okay, so this one is IDS. Great. So let me put a ground here. Okay, so this is our VGS, and this is the VDD, or the drain voltage. So now we are going to vary VGS and observe the current. Okay, so we go to analysis, DC transfer characteristics from DC analysis. Okay, so our input that will be changing is VGS, and output, since there is only one emitter here, so it will show IDS only, and we will change VGS from 0 to 5, and number of points is 100. So let's see what happens. Okay, so it is perfectly showing the output here. So the VGS is approximately, sorry, the threshold is approximately uh, 2 volts. 2 volts is our threshold. Okay, so thus you can import any spice model without worrying about errors. So you just give it to Gemini or ChatGPT or DeepSeek or any other AI sources, and it gives you the right syntax spice model that you can import in Tina TI. Thank you.